Hey guys, how's it going? Welcome back to part 4 of getting started with NumPy. In the last tutorial, we have seen the different array manipulation routines, especially how you can rearrange elements from uh, within the NumPy array. And also we have seen how you can transpose an array. In this tutorial, we're going to talk about the remaining array manipulation routine, especially around how you can add and remove elements within an array. And also we're going to see how you can join different array to create a big array. Again, this is not the exhaustive list of manipulation routines. There are many more things which you can do or perform on NumPy array, and it's practically impossible for me to give all the example in the tutorial. So what I can do, I will give you the link to the documentation of NumPy where you can go by yourself and explore all these routines by yourself. And if you have any questions or if you have any difficulty to understand any of these routines, please let me know in the comment section and I will try to help you there with best of my abilities. With this, let's get started. So the first array manipulation routine which we're gonna see is called insert, and this will allow you to insert value or values along the given axis before the given index or indices. Axis is the one which along which you actually insert value. If you do not provide an axis, it will just return a big flat array. And one thing you have to remember, this insert doesn't occur in place. It will just return a new array. So if you wish to in place anything, you need to reassign it to array itself. So let's see the example. So first you need to grab this method from the class np, then say insert, and the first argument it will take is the array itself, and the second argument is it will take is the index. So let's say I want to add any value at index number 1, and the value which I'm going to add is going to be 5, which is the next argument, and this is should be enough. Axis is optional, so if you do not provide axis as we have discussed, it will just return a big flat array where 5, the value, the desired value, is being added at index number 1. Now to avoid this getting array of a big flat array, you can provide axis here. So the final argument is axis. So let's say I want to add a new row 5 5 at 1th index. So that's what you got the return. Now also we talked this will not ensure the in place. So if you just print a, even after you perform this insert action, you will still get the same array, nothing changed. So this just return a big flat array. If you wish to capture uh, in place, then you need to reassign it to array again. Now if you will run it, you will get the desired output where the row 5 5 is being added at index number 1. Okay, the next method which you're gonna see is called append, and this will append the value to the end of an array. And obviously it takes 3 arguments, the array itself and the value and the axis. And again, axis is optional. If you do not provide axis, it will just return a big flat array. To give you a very concrete example, let's say you have created a 2 array np dot array, and here I will say 1 comma 2 comma 3. Oops. So let's create 1 by 3 shape array for x, and for y the same thing which you're gonna create and say np dot array. Then here I will create 4 5 and 6, and then here I will say 6 7 8 and 9. So 2D array. So the shape would be 2 by 3 for y. Now if I will just append these two things, so I will just say np dot append, and here I will say x, and which value I want to add? Y on the x. And if I do not provide x's here, I will show you, I will print it. You will say print it. You will get, oops, sorry, my bad. I should put comma here. Now if I will just go ahead and run it, you will see you will get a big flat array because we haven't provided the x's yet. In order to avoid this problem, you need to provide x's 0. So I want add in the row wise. So if you will just go ahead and run it, you get the desired output where this the second array is being just stacked over the first array x. Okay. The third method which we're gonna see is called delete. And this for this, let me create a new example. I have created a NumPy array. I will create, in fact, an array, and let me create a 3 by 4 matrix. Here I will say 1, 2, 3, and 4, and here I will say 5, 6, 7, 8, and here I'll say 9, 10, 11, and 12. Okay. Now this is a new this is a new array which has 3 by 4, and I need to close it. Okay. So this delete method will return a new array with the sub array along and given access deleted. So it take 3 arguments, the array itself, and the second is the index, and the third one is the access. Okay. So here will say np dot delete, and then the array delete, then array a. Then I will say I want to delete from the index 1. Okay. Now if I will just go ahead and print it, let me maximize this one a bit. Now you can see it's actually deleted, but it returns a big flat array because we haven't provided the axis. So let's define axis here. So I want delete a row. So if I will just go ahead and run it, now the row number or row index 1 is now deleted. Okay. So the fourth methods which you're gonna discuss about is called unique, and this will, as you can guess it, it will just return the unique, just return an array with a unique value. So let's say I will create an array, and here I will say 1 1 2, sorry, 1 comma 1, 2 comma 2, and 3 comma 3. So it all has duplicates. Now if I will just say np dot unique, and I will pass a, and if I will just print this one, you will see it will now return the array which has all the elements are unique. It's just like a replacement for the set, but here you will get the return as a NumPy array only. Okay. So now let's discuss how you can join different arrays. So here we will talk about 3 different kind of methods. First one is concatenate, that will just concatenate or join a sequence of array along a given axis or existing axis. And it is a bit similar to the append method which we have seen. And there is a special kind of concatenate which is B stacks and H stacks. And as you can guess it, B stack stands for vertical stacking, and that will stack array vertically or row wise. Similarly, H stack stands for horizontal stack. That means it will stack array horizontally or column wise. So let's see all this thing in an example. So here I have created 2 array A and B, and let's first talk about H stack or horizontal stack, or column wise stacking. So here I will say create another array called C, and I will say np dot h stack h stack, and then the the array which you want to stack, you need to provide it as a tuple. So A and B I want to stack, so I'm providing it as a tuple. And here I will say print c dot shape. Okay, now if I will just go ahead and run it, it returned. So as you can see, both the array, like first array A has a shape of 3 by 5 and the second array has a shape of 3 by 4. But when you do the edge stack or a horizontal stack, it grew horizontally and the column is being added, which is 5 and 4 become 9. Okay, and you have to note here one thing, that if you want to stack horizontally, the row has to be same. Similarly, if you want to stack vertically, the 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 column has to same. Okay, we will see in a minute the example of VStack. But before that, let me tell you how to do concatenate, how to do the similar thing by using concatenate method. So here you say concatenate, concatenate, and then you pass A and B, which you want to stack is a tuple. Then here you have to provide axis, or else it will not know how to concatenate, whether you want to concatenate in row wise or column wise. Here I want to concatenate in column wise, so I have to provide 1, or else would have provide uh, axis is equal to 0. Now for that, let me comment this one out. If I will just go ahead and run it, you will see you get the same output as previous. Cool. Now let's talk about uh, VStack or vertical stacking. So here, if I will just say from S stack to V stack, and if I will just go ahead and run it, it will throw me an error because I want to perform a vertical stacking, and for that the column has to be the same. So I need to change the shape here. So here I will say 16 elements, and here I will say um, 4 by 4. Okay. Now if I will just go ahead and run it, you see both the array A and B has the same number of column, only different in rows, and it just added, it just stack vertically, that it grew vertically, and 4 and 3 4 plus 3, the new array shape is now changed to 7 by 4. You can essentially do the same thing using concatenate method, and here to do that you need to provide axis as 0 because we want to stack vertically. That means row wise. So for row we need to provide axis is equal to 0. So if I will just go ahead and run it, you will get the similar output where 4 and 3 becomes 7. This concludes the array manipulation routines tutorial, and in the next tutorial we will see how you can perform various operations on arrays, NumPy arrays, and also we're going to talk about a very important concept in NumPy array, which is called broadcasting. As usual, if you have any question, please feel free to raise your voice in the comment section, or else thanks for watching. Thanks for all your likes and subscription. Until next time, cheers.